All right, so this is the final unit for the year, final lesson for the year. Woohoo! I just want to quickly run through one more thing with Half-Life. Um, I didn't want to make the previous ones that long. One of the things that, or one of the skills that they want you to be able to do is to determine the half-life of an element using a graph. And I'm going to just quickly show you how to do it. What this is here is you'll look at the time is at the x-axis, in other words, in days. The amount of sample that you have is here. So the way that you figure out the half-life using a graph is pick any 2 points. Usually it's easiest to pick the first 2 points that are listed. So I'm going to pick those right there. Okay. So here we go. Here's the point right here, and this one here. And notice that it starts out at 50 grams, your sample, and it goes to about 25. That is meaning that it cut in half. So the difference between each of these points is the half-life. So what you have to do is you have to translate that to the bottom scale, which means you're starting at 0, and this goes to about 25 days. So that difference tells you that the half-life is 25 days. And that would happen no matter how you did this. No matter what 2 points you pick, it's still going to give you the same amount. The problem is that when you get down here, it's much more difficult to tell the difference in the amount. So it's always easier to start usually using the first 2 dots on the graph. So you pick the first 2 dots on the graph, look at the difference in the amount, it's always going to be half, and then look at the difference in the time from 0 to that second point where it falls on the x-axis. In this case, it is 25 days would be the half-life. Again, they don't ask you to do that very much. He does kind of goes into way too much detail about the current uses of radioactive isotopes. Radioactive isotopes are used a lot nowadays in the scientific field, in the medical field, in manufacturing. So I'm just going to quickly run through and give you a listing of the ones that you need to know. Hopefully I'll find an empty spot here, right here. So I'm just simply going to write them down, and you just should write these down and don't worry about the other stuff. The most common one they ask about is carbon-14, and that is used for radioactive dating or carbon-14 dating. And that is used to determine if you find an object that was once living, so whether it's an animal or a tree, you can use carbon-14 dating to determine its age. And I believe it's good up to about 50,000 years. So it is used to date objects that were once living, whether it be a tree or some sort of animal, and I believe it's good for about 50,000 years. The second most common thing they ask about is iodine-131. Iodine-131 is used to diagnose, I hope that's correct, and treat thyroid disease, especially if you have cancer in your thyroid. So it can do 2 things. It can diagnose if there's something wrong with your thyroid, if it's not functioning properly, but it can also be used to treat your thyroid if it is cancerous. The next one would be cobalt-60. Is used to treat tumors, cancerous tumors. U-238, uranium-238, is used to date rocks, tell how old a rock is. And the last one, and they don't normally give you this, is americium. I don't even know if that's how you pronounce it, but I don't care. 241 is used in smoke detectors. Now, one of the other things that it's being used for nowadays, radiation, is irradiating food, and there's this whole debate about whether zapping food with radiation is safe. Does it change the food? Does it make it bad for you, in essence? So what they do is they'll take some food and they'll zap it with radiation, generally killing any bacteria that would be left. which means it would stay longer on the shelf. And again, there is a debate as to whether it changes the food either nutrition wise or makes it unsafe to eat. There are some people that refuse to eat food that's been irradiated, and I believe now that they actually have to indicate on the package if it's been irradiated or not. So if you're interested in that, you might want to look into that. And that is it, people, for this course. We are done, and we will begin reviewing